So hello everyone, welcome to another video of electrochemistry. So today we'll discuss about the Nelson cell or Kellner cell. Like this is the cell where we will discuss, like where we will take the nature of electrode which will be in the aqueous medium. Like in last time we have taken in the molten and now here we have in the aqueous, right? So we will totally discuss about the electrolysis of aqueous solution, and first here we will take the example of NaCl. Electro electrolyte of aqueous solution and we can say electrolyte of aqueous solution of NaCl. NaCl. Fine. So here you can see we have first NaCl. Yes, here we have NaCl. So now we are going to do the electrolysis of this NaCl. So as I'm going to take the aqueous medium, so aqueous solution, so here you can see water will be added and it will form ions, two Na positive ions plus chlorine negative ions 2. Why I put it 2? Because I have to balance the equation. So that's why I have applied 2 on the both side of the ions. So those both ions now these are in the aqueous form, right? So now the reaction of this NaCl at anode. First we will see the reaction of this NaCl at the anode. Fine, so here you can see first we have what? First we have 2 chlorine, because anode is the positive charge, so at the anode the negative charge will be attracted, and in the NaCl the negative charge is chlorine, so that will be we can say attached at the anode. So chlorine will give Cl2 plus 2 electrons. So this means this is losing the electrons, and whenever any substance, any element lose their electron, the process is known as oxidation. Oxidation. Fine. After that, here, so now here you can see at the anode the OH oxidize. Yep, from the OH will not oxidize faster, but chlorine will oxidize it faster because chlorine have more electronegativity, like this, right? So now here we have another reaction at we can say cathode. So as you can see, the reaction of cathode, as cathode is negative charge, so positive ions will go and attract at the cathode. So those are Na positive. So we are here we were having 2 Na. Okay. So 2 Na will, we can say, gain. Okay, so as here we have taken what? As here we have taken the aqueous medium. So for that aqueous medium, the water will be also, we can say, will be reduced. So here we have first NaCl. Na will be reduced into, we can say, Na, and sorry, will gain 2 electrons. Na will gain 2 electrons and reduce to 2 Na, right? 2 Na. Fine, so this is the reduction. Same here, the water will be reduced. H2O will be oxidized. H2 क्या होगा? ऑक्सीडाइज हुआ H पॉजिटिव प्लस OH नेगेटिव. तो अब आप देखो इस रिएक्शन के अंदर क्या होगा. इस रिएक्शन के अंदर बेसिकली हमारे पास जो वो है कंसंट्रेशन है. पहले तो हम ऑक्सीडेशन की बात की जाए. रिडक्शन के अंदर अगर हम बात करें ऑक्सीडेशन की, तो क्या हो रहा है हमारे पास ये OH जो नेगेटिव है वो भी कैथोड के साथ अटैच हो सकता है, और क्लोरीन जो नेगेटिव है वो भी कैथोड के साथ अटैच हो सकता है. तो अभी ये इन दोनों की चांसेस हैं, ये दोनों कैथोड के साथ अटैच और सॉरी एनोड के साथ अटैच हो सकते हैं, बिकॉज दे बोथ कंटेन द नेगेटिव चार्जेस. अभी नाउ हियर इन दिस केस, इस केस के अंदर हम क्या करेंगे, इस केस के अंदर हम देखेंगे टेंडेंसी, किसकी टेंडेंसी ज्यादा है ऑक्सीडाइज होने की. तो दैट विल बी ऑक्सीडाइज. वी विल सी द टेंडेंसी to get oxidized. Fine. Same as a cathode. Cathode की तरफ भी क्या होगा हमारे पास? Cathode की तरफ भी like in the रिडक्शन, वहां पर भी क्या होगा हमारे पास Na positive and H positive. They both are the elements which will be attached to the cathode. So now here we will see where the reduction will take more. Okay, कहाँ पे reduction ज़्यादा होगी, right? So yeah, so for this we will again see the tendency. We will see the reduction potential किसका ज़्यादा होगा. So now remember series, in the series, as per series, chlorine is have the more tendency to oxidize. क्लोरीन के पास ज्यादा टेंडेंसी होती है ऑक्सीडाइज होने की. This is we can say related to reduction potential or electro, we can say series. Those series we will discuss in the next video, right? So chlorine have more, we can say, tendency to, we can say, oxidize. So here chlorine will be oxidized. Again, here you can see in the cathode H positive have tendency to be reduced. H positive के पास ज़्यादा tendency है reduce होने की. So this means from this cathode reaction H positive will go. So here we have two H positive plus two electrons give H2, reduction take place, right? So I think these both are clear. Like it will be further clear. We'll discuss about the electrochemical series, right? So yeah, here you can see now we have what? Now we have remaining. What is remaining? Remaining is OH. It will be plus 2 OH plus 2 Na positive. These both are remaining. Now they both are, as you can see, this is what? This is the basic. So this means they will increase the pH. ये क्या है? ये basic solution है. So they will, pH will be increased. pH will be increased. Okay. So yeah, here you can see now as after that, here we have in the if we are going to put the, we can say, electrode, so same reaction will occur. Okay, I hope that it is clear. Now we are going with another example of the aqueous state, right? So another example would be yeah, our another example is electrolytic of sulfuric acid. अब हम क्या करेंगे? हम sulfuric acid की electrolysis करेंगे, right? So let me write here electrolysis of sulfuric acid. सल्फ्यूरिक एसिड. ओके, तो हम क्या करेंगे? पहले तो वी हैव नो सल्फ्यूरिक एसिड 2H2SO4 will break down in the presence of water and give 2H positive plus SO4 2 negative, right? So now here you can see first we will talk about the reduction at cathode. कैथोड पर रिडक्शन की बात करेंगे, then oxidation at anode. So as you can see, which one will be reduced? So we know that K2H positive will be reduced to H positive plus 2 electron give H2, right? Because we know K2H positive have higher electrochemical series than OH. H positive. So that's why we'll take H positive, right, in the reduction. Now in the cathode, we can say oxidation at anode. So here you can see anode we have O2 gave half oxygen plus 2 electrons plus H2. So why I have taken OH here, not SO2, SO4? Because OH have more tendency to oxidize. However, SO4 have less oxygen to be oxidized, right? H2 के पास less वो है, you can say, tendency, and OH have more tendency. Now, if you talk about the aqueous solution, or you can say electrolysis of CuCl2, ठीक है, copper chloride. So copper chloride will be broken into with the help of water into ions plus 2 chlorine, right? So now here you can see in this reaction will take place at the cathode, which will be 2 plus 2 electrons and give Cu reduced. Cu reduced. So why I haven't taken H positive? Because Cu positive have more tendency than H positive. After the reduction at anode, if I to talk about, so 2 chlorine gives Cl2 plus 2 electron. Now chlorine have more tendency than H2O, sorry, OH. That's why I have taken chlorine here in the oxidation. So I hope that it is clear to you guys. Now let's make a chart of this. It will be furthermore clear to you guys. So if I can make here the chart. um, as last video we made the chart of the molten. So now we are making the chart of the aqueous. So here we have aqueous, here these three, right? So we have first aqueous NaCl. So NaCl from NaH2 will be, we can say, cathode, product at cathode and at anode. So H2 will be product of cathode and chlorine will be product at anode. Then we have NaNO3 in the aqueous solution. So with this here you can see the H2 will be cathode and same we can say O2 will be at the anode. Okay, O2 will come from water because NO3 have the less electrochemical series, tendency less tendency. Same H2SO4, here we have hydrogen, here same oxygen. Then CaCl2, calcium chloride, here we have H2, here we have chlorine. So this is the, we can say, table where you can easily identify. I hope it is clear. Till that, bye bye.